I'm Anil Kumar. Let me thank all the viewers and subscribers for watching my videos and sharing brilliant questions. Here is a test paper from one of our subscribers. I'm going to solve this test paper and I hope many of you will benefit from it. It is based on fundamental theorem of calculus. So there are 5 questions in it. We'll take up questions based on definite integrals here. Question number 1 is, show that the definite integral from 1 to 2 of 6x plus 4 divided by square root x dx is equal to 16 square root 2 minus 12. So let's solve this question. So the definite integral which we need to find is from 1 to 2, 6x plus 4 over square root of x dx. So let's split these terms and simplify. So what we get here is 6x over square root of x plus 4 over square root of x, correct? So we'll find the integral of this. Now that could also be written as from 1 to 2, 6 square root x, right? Plus 4, we can write this as x to the power of minus half. Dx. Okay. Now applying the rules, what we get here is 6 times x to the power of half plus 1, which becomes 3 over 2, right? Divided by 3 over 2 plus 4 times x to the power of minus half plus 1 will give us half, right? Over half from 1 to 2, correct? Now let's write this as so dividing, multiplying, so we get 12 over 3, which is 4. So 4 x square root of x cube, right, plus this gives you 8 square root of x, correct, from 1 to 2. So let's evaluate and show that this is equal to 16 square root 2 minus 12. So this could be written as, we can now multiply, write this as 2. So we get 4 square root of 2 cube plus 8 square root of 2 minus 4, substituting 1 now, plus 8. Right? So that gives us equal to, now we have square root of 2 cube, so let's rearrange and that could be written as 4, right? When you do cube root, 8, right? So 8 gives you 4 times 2 square root 2, correct? That is square root cube plus 8 square root 2 minus 4 minus 8. So that is 8 square root 2 plus 8 square root 2 minus 12, and that is 16 square root 2 minus 12. So that is the right side. Is it okay? So that is how you could prove this. Now let's take question number 2, which is dy dx equals to 2 over x squared plus 4x, y equals to 3 when x equals to 2. Determine the value of y when x equals to 5, right? So we have dy dx equals to 2 over x squared plus 4x. Now integrating both sides, what do we get? So when we integrate both sides, we get y equals to, let me write like this. Okay. Okay, so basically we'll take dx that side and then integrate. Okay, let's do it like this. So y equals to, so when you integrate this, you get, let me rewrite, 2 times x to the power of minus 2 plus 4x dx. I messed this up, so we take dx to that side and write it like this. Okay, so what you get here is 2 times x to the power of minus 1 over minus 1 plus 4 x squared over 2, right, plus c. That is what you get, right? So this is y is equal to, so you get minus 2 over x plus 2x squared plus c. Now we are given the initial condition, which is y equals to 3 when x equals to 2. So let's substitute x equals to 2 here and y equals to 3. So we get minus 2 over 2 plus 2 times 2 squared plus c. So that is 3 equals to minus 1 plus 8 plus c, and 8 minus 1 is 7. So we have 3 minus 7 is equal to c, which is equal to minus 4. Correct? So we get a value of c as minus 4, and now we can write y as equal to minus 2 over x plus 2x squared minus 4. Correct? So we are substituting this particular value of c equals to minus 4 from the given initial conditions into this equation, right? So initial condition was y equals to 3 for x equals to 2. Clear? Now the question is, determine the value of y when x equals to 5. So we'll substitute x equals to 5 here and find the value of y. So we get y equals to minus 2 over 5 plus 2 times 5 squared minus 4, and that is, we can write this as minus 2 over 5 plus 25 times 2 is 50 minus 4, right? So you could, that comes in decimals, so 20 divided by 5 is 0.4, so we could write this as 46 minus, so 0.4. So that gives us 45.6, correct? So that becomes the answer, right? Now let's take up question number 3. Now question number 3 here is the graph from where we have to find the area, right? So let me share with you the question here, which I have taken directly, which says the graph of the function f of x is shown below for x between minus 3 and 3. The area enclosed between the graph, the x-axis and the lines x equals to minus 3 and x equals to 3 are marked in the appropriate regions. So see, the area is also mentioned here, right? So area of this portion is 3, 4, 4 and 2, right? So that is how the graph is. Now what do we need to find? So a couple of things which we need to find is, the very first one is the value of integral from minus 2 to 3, so from minus 2 to 3, f of x dx. So this should be equal to what? So when we find the value of integral, the negative is taken as negative, right? So we are talking about this portion from minus 2 to 3. So the area here is minus 4, area here is positive 4, and then here it is minus 2. So when you add them up, you get minus 2 as your answer, correct? Okay. The next one here is part B, which is area enclosed between the graph of f of x and the x-axis from -2 to 3. Now we are talking about area enclosed. So when we say area enclosed, it is you have to add absolute values, right? Add absolute values. So in this case, we get the area as equal to 4 plus 4 minus 2. 4, all added. So 8 plus 2 is 10 units. Is that clear to you, right? So that is how we are going to answer this. Now let's take part C, which is the value of integral from 0 to 2 x minus f of x dx. So this could be written as integral from 0 to 2 of x minus integral from 0 to 2 of f of x dx, correct? Now as far as the integral of x is concerned, it can be written as x squared over 2 from 0 to 2, right? Minus, we have already found the value from 0 to 2 integral, which is, okay, let's go back to the graph. So that's the area enclosed, right? So from 0, that is 0, to 2, the area enclosed is 4 positive, right? So that is what that answer is going to be. So we'll write here minus 4. Is that clear to you, right? So from the graph, correct? Now let's calculate this, which gives us as equal to, that becomes 4, right? 2 square is 4 over 2 minus 4, and that is 2 minus 4 as minus 2, correct? So that is how we are going to solve this particular question. So I hope the steps are absolutely clear. Now let's take up the next question, which is based on the fundamental theorem of calculus. So here we need to evaluate the integral from 1 to 2 d dx of x cubed over x squared plus 1. Now in this particular case, what are we going to do? Since it is integral is after taking the derivative, we need to apply these limits, right? So the integral from 1 to 2 over for d dx of x cubed over x squared plus 1 dx can be written as x cubed over x squared plus 1 from 1 to 2. Clear? So that is how we are going to evaluate this. So let's substitute. So when you substitute 2, we get 2 cubed over 2 squared plus 1 minus 1 cubed over 1 squared plus 1. Correct? So we get 8 over 4 plus 1 is 5 minus 1 over 1 plus 1 is 2, right? So that's what you get. Common denominator being 10. You get 16 minus 5 or 11 over 10. Perfect. So that is how you're going to answer this. The last question here is d dx of integral 4 to x squared 2 over 3t cubed minus 1 dt, right? So we'll apply the fundamental theorem. So in this case, it is going to be the integrand, which is 2 over 3, t is x squared, right? So x squared whole cube minus 1 times the derivative of x squared. Okay? So you need to apply the chain rule here. So what we get here is 2 over 3 x to the power of 3 times 2, 6 minus 1 times 2x. Is that clear? So we get 4x over 3x to the power of 6 minus 1. Correct? So that is how we are going to solve this particular question. So I hope the steps are absolutely clear. Now for this, where we have used the chain rule, I'll give you a link where we have discussed this at length. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Once again, thanks for sharing the test paper and all the best.